anybody joining on the West Coast. I just want to say thanks for spending a little bit of time with us here for another XenTegra webinar. And I know my slide says Lunch and Learn, but most of you were at a XenTegra Lunch and Learn about Nutanix and Cohesity recently. And so we wanted to offer a deeper dive, hands-on into the Nutanix infrastructure, how it works, and also give you a chance to be hands-on with a lab. So I'm working now to go ahead and send out some information for how to get into the lab. But I want to say on behalf of the entire XenTegra team, welcome. Thanks for joining us. And we'll go ahead and give people just a few minutes to get into the room. So we'll kick off the content about 5 minutes after the hour. But just kind of getting ready for things. If you've got questions or things you'd like to see and for us to highlight today, go ahead and drop those into chat. We'll be monitoring the chat throughout the day today. So just feel free to use that. We want this to be as interactive as possible. There's also a Q&A function here inside of Zoom. So you can use that to ask your questions as well. And what we'll do is I'm going to go through and allow everyone the ability to talk. So that should be lighting up inside of your Zoom session. So feel free to ask questions as well. And as I said, we'll kick off here around 1:05 Eastern time. So everybody should be allowed to talk. We'll be watching that, but feel free to say hi or ask any questions as we get started.
Hello. Good afternoon.
Good afternoon, Chris.
Hey, how you doing, Philip?
Doing pretty well. How about yourself?
I'm good. Do you prefer Philip or Phil? P-Dog? What's up?
P-Dog will be a new one, and I'm afraid anybody who's from XenTegra listening may not let me live that one down.
Thanks for that, Chris.
You're welcome.
I tell people I've answered to horrible things in my life, so Phil or Philip doesn't bother me. I'll take
right.
One.
Okay. Good deal.
So for everybody just joining in, we'll kick off around 5 minutes after the hour. Just want to say welcome again, and thanks for spending some time doing a deep dive into Nutanix.
Thank you for the invite.
Lowell, I see that in the chat there. Not going to forget about P-Dog.
Christmas came early this year. The good thing is it fits as easily on a hat as it does on a t-shirt. So.
Oh, the ideas keep coming. That's scary. Well, I think we're at that time, so I'm going to hop back on video and we'll get things started today. So again, thanks so much for spending time with us. Part of what we believe deeply here at XenTegra is an educated customer is the best kind of customer. So we spend a lot of time doing freely available events like today's webinar, like the lunch and learns you may have experienced, and some of the other fun events that we do. But today we want to go deep. This is going to be a technical session. We'll go as deep as you guys want it to go. Want it to be very interactive, and make the most of it. So we'll go ahead and kick off. We are recording today's session, so for anybody watching back on our YouTube channel, want to give you a quick synopsis of who we are here at XenTegra. So first and foremost, we're a value-added reseller. And so that means you can buy stuff from us. You can buy hardware, software, licensing, and we work hard with our manufacturing partners to get the best status, which leads to the best discounts and best pricing for you as a customer. So that's the first part of our formula, but that's not necessarily the biggest thing. We take that value added part really seriously. And so we try to put value back into the world through events like today and through other investments that we'll talk about in just a minute. In addition to being a reseller, we're also a professional services or consulting services partner. We're able to help you get things done in quick order when you have a new technology, a new project, or you need some assistance. We can come alongside you and help you succeed. And then when you need more than just that tactical service partner, we're also a managed service provider. But we do managed services a little bit differently. We like to think of our managed services as co-managed services because we're not here to displace or outsource your job. We're here to come alongside you. We think that you will know your organization more deeply than we could ever know it as an outsider. And so we try to come alongside existing IT pros and teams and help you succeed by giving you specialized knowledge in certain areas, giving you time back to invest in more strategic and valuable tasks within your organization. And as I said, one of the ways that we add value back into the world is through our complimentary assessments. These are 4-hour or half-day virtual assessments on some of our focus technologies. And you can see some of those focus vendors across the bottom of this slide. Technologies like Citrix and Nutanix, ServiceNow, and Microsoft. We've got a number of different assessments that we do on their technologies to help you gain value. Everything that we're trying to do here is to get the most out of your investment in their technology stack and in the software investments you've made. And so with those technology assessments, you get to know our team. You can see what we're made of and make sure that we live up to the hype, to the marketing that we put in front of you about who we are. And so it's a no obligation way to meet some of our technicians, get value back to your organization. And that's for new customers and existing customers. You can make use of these assessments. Some of the other ways that we add value back, today's webinars, one, we do lots of hands-on workshops. We've got a number of different vendor-focused podcasts, and since we're talking about Nutanix today, I'll go ahead and point out that I host a Nutanix podcast for XenTegra, and we've got lots of different technologists that join us on that podcast and talk about what's going on, what's news, what's moving forward inside of the Nutanix ecosystem. And then perhaps my favorite thing that we do, we help you go to conferences. And so we're just unwrapping our conference program for 2025. And I can tell you, as a Nutanix customer or someone interested in Nutanix, we would love for you to go with us to Nutanix.next next May. It's going to be hosted in Washington, D.C., and this is the big Nutanix conference, and we can help you get there. So if that's something that you're interested in, we've got a website page, and Chase on our marketing team is putting some links into the chat for you right now. But we would love to be able to get you into that conference pass program. And so I don't know if we have that sign up sheet ready yet. It looks like we do. So Chase has got the link right in there. If you want to get in on that conference pass program, go ahead and sign up there. And we would love to host you, help you get connected, and learn anything that we can help you learn about Nutanix in person in Washington, D.C. later next year. So for today, who's talking at you? I think I know most of the folks in the room, but my name's Phil Sellers. I'm the director of Modern Data Center for XenTegra. I've been with the company a little over 2 years now, and I live in the Charlotte, North Carolina area. I have about 25 years of experience in the IT industry. I've been a consultant. I've worked on staff for a couple of private firms, in lots of technical roles, from being a systems administrator all the way up to a director of infrastructure, overseeing budgets and working with the CFO and COO of our company to make plans and forecasting for the future. So I've sat in seats very similar to yours. In addition to that, I've always been interested in doing other things. So I've had a blog, I've done podcasting, and a lot of those things have turned into really valuable things now that I'm here at XenTegra. But my heart's always been to just invest back into the community and help other people learn and avoid the problems that I've encountered. So um, I happened to get the surprise of my life back in February when Nutanix announced their Partner Sales Engineer of the Year, and my name flashed up on stage. That was pretty cool considering I haven't been in the Nutanix space for all that long, just a couple of years that I've really been focused in on their technology. I grew up as a VMware guy and really was impressed with what I see and what we're going to talk about today in terms of Nutanix and what the technology can do and how the core innovation has really moved forward. But I'm not alone today. I've also got my pal, Paul Nguyen. He is our senior channel sales engineer. And Paul, I'll turn it over to you to introduce yourself.
Yeah, good afternoon, everyone. Thank you so much for joining today. Again, my name is Paul Nguyen, Senior SC with Nutanix. Been Nutanix now for 7 years, and couldn't have worked with a better partner like XenTegra. So you guys are in amazing hands with Philip today. And yeah, we want to keep this as interactive as possible. So ask us any questions. While Philip presents, I'll be monitoring the chat for any questions and answers.
Yeah, Paul's my tag team partner. He taught me a lot of what you're going to hear today. And so I'm incredibly grateful to have Paul on the session with us. And so, again, as we go through this, we want this to be interactive and valuable to you. So I think that's enough for introductions. Let's dig into the meat. So if you came to one of our lunch and learns, you've seen this slide. This is the Nutanix World slide. When I talk about this, we're looking at everything that Nutanix makes. And so there's a ton of different places we can focus in. These are not necessarily products per se, but they're building blocks or they're enablers for services that you can deliver out from within this platform. One of the things I've been saying a lot lately is that there's differentiated value that VMware doesn't have in their platform that we find here in Nutanix. Database services, for instance. Database orchestration is not something you can buy as a product or a service to bolt on to VMware at this point. There's a lot of things that may look the same between the two platforms, but are incredibly simplified here in the Nutanix platform. And so today, what we want to do is not try to boil the ocean and talk about everything on this slide. We want to dig in specifically to the cloud infrastructure piece and the advanced HCI functionality plus the scale out storage. And this is really the heart and soul of the Nutanix platform. Everything else that surrounds it really taps into this core technology. And so it's pretty common to hear people in the industry say, oh, I know Nutanix, they're that hyper-converged company, that's all they do. As you can see on the slide, there's so much more that Nutanix does as a company, but there's some truth to that. That is what they do. They invented hyper-converged, which is the idea of taking commodity servers, putting local disks into those, layering on software, and then creating a scale out storage system using those commodity servers. And so that's true. And every other product that we talk about, whether it's unified storage, Kubernetes, database services, enterprise AI is a hot topic. All of those tap back into that core storage service we're going to talk about and learn about today. And so that's really where we're going to focus in our time. So AOS, Acropolis operating system. That's what Nutanix calls its core software as a storage. Software-defined storage. I'll get there today. AOS is a software-defined storage play, and this is the core of what works for our benefit to create this scale-out architecture with Nutanix. So AOS, we'll talk about AOS, and a lot of times I think it's easy to think about AOS similar to VMware and it being a hypervisor, but that's not the case. AOS can work with 3 different hypervisors. It can work with ESX from VMware, it can work with Hyper-V, or it can work with the built-in enabled AHV or Acropolis hypervisor from Nutanix. So you have choices here when it comes to the Acropolis operating system. Now that same software, the AOS, runs in every cluster that runs Nutanix, no matter the hypervisor and no matter the location. As we kind of talked about in our Lunch and Learn series, today's IT environment has a lot of challenges. There's environments constantly in flux. There's workload patterns that are going to change. There's data growing unexpectedly as we have new ways of creating data, software sensors in the edge, and all of this crazy growth in transactions and digitization of your business. And then on the other side, we also know we're working with hardware components. They're going to fail. They're going to have issues. And so what we believe is that a modern approach applies a distributed system principle to solve these problems. We should expect failure, and we should be able to handle failure in real time with self-healing technology so that it automatically fixes the issue without human intervention. We want to eliminate single points of failure so that there's no single point of control. We want distributed concepts to help us survive so that if one critical system component gets hit, that it does not take out the bigger system. We want it to be easily scalable. We want to scale infrastructure on demand. And so some of what we've talked about is right sizing, a concept that we often talk with customers about as we're creating a design or solution around Nutanix is right sizing. We don't have to build today for your top usage over the next 5 years. We can easily add to this solution and grow it over time, which equates a lot of cost savings upfront and throughout the life of your solution. You're not buying a storage array for what might be the tip top of your use on someday 3 years in the future. You don't have to get your crystal ball out and really start figuring out what's the worst that could happen and plan for that. You're able to do things in a much more granular, today-centric sort of design with the ability to grow in the future. There's also no rigid design choices, meaning there's no specialty hardware. There's no ASICs. There's no add-in cards. There's no functions that are handled by this place or this node in a system. Things are all distributed equally across the cluster nodes. And so you get to have a level of independence and choice, which we talk a lot about with Nutanix. You get choice of vendors, hypervisors, locations, and all of that choice is because there's no specialty hardware behind the scenes. It's also incredibly important that this is a software play. Nutanix is a software play that easily adapts to the next hardware technology change. And so we've seen several of those over the course. When first introduced, Nutanix used solid state as the fast tier and hard drives as the capacity tier. And over time, that changed. Solid state became pretty cost effective. And so everyone was running all flash, all SSD. And then today, what we find is we've skipped from SSD to NVMe, same technology, different bus, now moving from a SCSI bus to PCIe. And we get to benefit from that extra speed. And the software has kept up with that. We'll talk about that today in more depth. But at the same time, we're reusing proven technology. So there's special use cases in the secret sauce inside of AOS where they're being used to handle certain specialty use cases. And so this is reuse of proven technology. Now, what does this all mean across the board? Well, it's pretty flexible. And that's the outcome that we're looking for. Because we've got a scale out system here, it becomes a really flexible option for a lot of different use cases. So whether that's VDI, whether that's primary hosting, whether that's databases, you now have a common way to simply run all of those different things from a single platform. Now, as we talk about these distributed system principles, one of the things you may notice is it sounds a lot like cloud native. It sounds like the way Microsoft is building Exchange Online and Azure Active Directory and all of these. You're right. These distributed principles really are cloud native principles, right? We expect failure, no single point of failure, scale, no rigid design choices. That's exactly what Nutanix is putting into your data center, is a cloud operating system. And so because it's built on those same principles, every layer built on top of this storage system now gets to benefit, and you can run cloud in your data center. And we'll talk more about that as we go. So centralized systems, traditional 3-tier. At the bottom, what you see are 2 controllers and a bunch of disks, generally in some external storage array. All of these dotted lines are your fabric connecting your servers to that storage. That's the traditional way of doing things, but there's drawbacks. It's difficult to scale out. It's complex and rigid configurations. You're buying possibly a purpose-built SAN just for this network communication. So if you're fiber channel, you may have a completely separated, completely different type of switching. If you're iSCSI, you may be running this on the same converged Ethernet fabric, but at the end of the day, there's still a lot of different configuration that you have to handle in 3-tier. It's also inefficient, primarily for the reason we talked about. It's hard to right size and grow later. There are ways you can do this in the traditional way, but at a certain point, you will saturate the performance you can get out of those 2 controllers in the purple boxes here in the middle of the screen. Those controllers become your biggest bottleneck when we talk about traditional centralized storage. Once you hit that bottleneck, you're not adding any more performance. It doesn't matter how many disks you put behind it. Yes, you can grow capacity, but you can't grow performance. So let's throw that all away. Let's refactor this, add local disks to the node, and then let's pull those together and create a storage pool. We call this the distributed storage fabric. AOS storage here in the middle eliminates that need for centralized storage. And those dual controllers we talked about in traditional storage have now moved into this CVM, or the controller virtual machine. This is the brains of a Nutanix cluster. And because this runs on every single node in the cluster, you see it on node 1, node 2, and every node after, you get the same functionality in every single node that you add. So that gives you resiliency, the ability to fail over and fail back, and recover from failures in a variety of different ways. And because this is a distributed storage fabric, it also protects the data. And we'll dig into that a little bit more. We'll talk about the data protections and the way that the software handles that across nodes, rather than using traditional methods of RAID technology inside of a RAID card in a single server. Now we're talking about that same concept applying across many nodes. So this is true scale out. Every time you add a node, you get more performance and you get more capacity. All of these resources are designed to self-heal. You get dynamic data placement. So within the software, you're given control of how do you place this data. Do you need one, do you need, well, I guess one could apply, but do you need 2 copies of the data every block? Do you need 3 copies of the data? Do you need compression and deduplication? And I'm giving away all of these different capabilities we'll talk more in depth about, but you get to set all of those settings on a per VM basis. And so once you create that storage container inside of Nutanix, it's going to have certain things turned on or turned off. You can assign that to any VM that needs those settings. Also, data locality. One of the pieces of secret sauce here inside of Nutanix is data locality. We'll look at that in depth in just a few minutes. It's also simple and efficient. So this is one of the claims to fame with Nutanix. They call themselves silo breakers because you no longer need a dedicated storage team that does something completely different than the rest of your team. One single team can manage Nutanix, the storage, and everything else, all from a common set of things. So we get to call them silo breakers, and through common UIs and the ability to work everything from the same set of screens, you simplify the overall process. And lastly, we've got resilient and protected data. Writes are always replicated. Your user data is protected and rebuilt on failures. And so, as we said, we expect failures out of this system. So we're constantly working on ways to optimize performance while also keeping that data protected. So I do see we've got a question from Joe here in the chat. So quick question, in Nutanix, is it possible to hook into existing external storage arrays for specific use cases? No, it kind of defeats the purpose of hyperconverged philosophy, but if we want to leverage some existing storage that we've already locked in for X number of years, how might we be able to leverage that inside of Nutanix, if at all? So the answer to that, Joe, is today there's not a way to do that, but it's on the roadmap, and we have our first external storage array that has been talked about publicly. It's Dell PowerFlex. And so coming soon, Nutanix has publicly said, and so has Dell, they have partnered to bring storage support for PowerFlex. Chris asks, is it just PowerFlex and not Store? Yes, today it is just PowerFlex. We can't really, guarantee anything in the future, but this is a pretty big change, as Joe kind of alluded to. We've gone from a pure hyperconverged strategy to supporting some external storage arrays. This is something where we can possibly expect others in the future, but there's no concrete announcements or timelines. Nutanix and Dell have publicly said they're bringing this to market, and so we're waiting for the official announcements, but that is the first, and so we will see. So I would say in the near term, just keep watching. Might be a good reason to be at .next to see what the latest announcements are going to be come May timeframe. So I would say stay tuned, and we'll keep you posted as those things develop as well. Thanks for the questions, guys. So let's talk a little bit about flexible scaling. So in the hyperconverged, you may have to, or in some designs, you have to match all of your nodes. They have to be the same size, the same disk, the same configuration. It's not the case with Nutanix. You can mix and match your nodes. There are some guidelines and best practices around how you mix and match, But over time, you may end up needing more storage, or you may end up needing more compute, but not storage. There's flexible ways you can grow a Nutanix cluster. So as we said, when you add a new cluster, you get more performance, you get more capacity. That scale can be independent. If you're doing a storage refresh, let's talk about that first. So let's say you've got generation 8 hardware, you want to go to generation 9 hardware. Well, guess what? You can mix 8 and 9 together. You add a node in, it grows the cluster, you can take an old node out. And so we work with a lot of customers, and that's the way they life cycle. We have NX generation 6, which is Nutanix white box hardware. That's gone end of life. 7's gone end of life. We've worked with customers to add generation 8 and 9 to those clusters, pull the old nodes out, and everything continues to run, zero downtime. It's a very easy migration path. But there may be a case where we need more storage. So we have the ability to add storage heavy nodes in the same cluster. So different configuration to handle additional storage needs within a cluster. The data is automatically going to get rebalanced, and Nutanix software is going to take control of handling how that data gets spread across the cluster nodes based on how they're configured. You can also add storage-only nodes, meaning we're not running any virtual machines here. We're just adding additional storage, capacity, and performance to an existing cluster. So this is pretty handy in use cases where you may need an archive or things like that added into a cluster. But it becomes really, really interesting when we talk about you can add compute-only nodes as well. And so if you had storage-only nodes and compute-only nodes, guess what? Now you can run these heavy databases and not have any extra overhead of running things on the same cluster. So, or on the same node. So we have lots of different things. We know that you pay a premium for Oracle licensing and SQL Enterprise licensing. So you have the ability to also do compute-only nodes. And so really across this is another element of choice so that you can grow as you need on any of these dimensions, compute, capacity, or IOPS. Lowell's got a question here. As you are growing clusters, are you saying the nodes don't have to be identical hardware or even the same vendor? So I am saying they don't have to be identical hardware. At this point, they do have to be the same vendor. We grow within the same vendor technology for a number of reasons, but the way that we handle lifecycle management is one of those reasons. And so we want to be able to patch the firmware and drivers and everything. So we do like to stay within the same vendor within a cluster, but we definitely can grow different configurations, different generations. So they don't have to mix, they don't have to match identically. So let's talk about the dynamic placement and movement of workloads. So we've got a virtual machine here shown in purple running in this 4-node cluster. And one copy of the data is always written locally where the virtual machine's running. As the data copies, we also distribute that dynamically across other nodes. So block B here in this case gets written to the second node. Now block C gets written to the next node. So there's a lot of different algorithms that go into how do we place the data across the cluster. Some of those different metrics that are used are here: usage, response time, queue depth. All of those go into the placement of data. And then there's back-end processing and things that happen. Do we have copies of all of those different blocks of data across different nodes? Are they accessible? Do they match? All of that cleanup, that health check is going on in the background as well. There's not just the idea that it was written, therefore it is healthy. The processing inside of the CVM is actually going out and making sure that everything is still good to go. But what happens when a virtual machine migrates, either using vMotion or live migration in Hyper-V or AHV? So now our virtual machines move from node 1 to node 2. And you'll notice that all of the data was sitting locally on node 1. So we had all 3 different blocks, A, B, and C there. Well, what happens with the function of data locality, we relocate those to where the VM's actually working. And so that provides the ultimate performance. And as we talk about performance, data locality is a big concept that accelerates performance within a Nutanix cluster. So when things happen like vMotion and migrations or a failure and a restart of a VM, the cluster is automatically going to bring all the local data for that VM locally and keep it there so that everything can run just as fast as possible. In addition to that, we've got local metadata stores. And so this has also been another huge help in terms of keeping data. So there's not some large metadata store anymore. Now we've got these local copies. This gives us better performance to that metadata, which is critical in a deduplicated storage system. And so this is true within any storage system, whether it's Nutanix or traditional storage. That metadata becomes really important. So fast access to that, this accelerates things. So we keep these local copies of the metadata updated from that global metadata, and this allows us to also fast recover and fast heal from a failure of any type. So why does it matter? Linear performance scaling with flexible capacity. This is a differentiation from their competitor. You've also got automated provisioning and scaling, and those give you 2 outcomes: reduced operational cost, and they reduce risk and the CapEx by allowing you to start small and grow as required. So a couple questions over here I see. Does the metadata have presence between clusters? No. So clusters are going to be your boundary for metadata and for any of the storage operations. So when you form a cluster, that boundary becomes, true for your deduplication, compression. And so each cluster is fully autonomous. We manage those, as Paul was answering here in the chat, from something called Prism Central. On the cluster virtual machine, so if we go back to this slide, on the CVM, we run something called Prism Element, and that becomes the manager of a single cluster. And so Prism Element exists within that boundary, just like your metadata does. And so we can do everything for a single cluster within Prism Element. But when we manage multiple clusters, that's where Prism Central comes in. If we do have needs to replicate, we do have that, and we'll talk a little bit about disaster recovery in a few minutes, but we have the ability to replicate data between clusters, but primarily your cluster is a boundary. It's a set boundary for AOS. And that's also true when it comes to the storage pool. So all the disks inside of a Nutanix cluster and its nodes get contributed into a single storage pool in a cluster. There's generally no reason basically to have more than one. I know it's common sometimes in vSAN to think about this concept and have different pools of storage. That's not the case inside of Nutanix. AOS consumes all the disks, puts them into a single storage pool, and then any differences you need on a per VM basis are handled with storage containers and settings. So it's an abstraction away from the disks that control how many copies of data, is there compression, is there deduplication, all of those kinds of things. So when we talk about a cluster, your AOS storage, that is a boundary within the cluster, and the cluster is a boundary for the storage pool and its metadata and all of the associated data inside. Great questions. Keep them coming. So let's let's talk about resiliency and data redundancy. So I know it's probably nice to hear that there's this magical thing happening behind the scenes, but it's better to understand what's that magic, right? Um, cluster resiliency, we have a concept of fault tolerance. And so this is the number of component failures that a cluster can tolerate before the cluster goes down. And so in a distributed system, we have to talk about this cluster fault tolerance. You can choose your FT level for a cluster. So FT of 1 can tolerate 1 component failure, where an FT of 2 can tolerate up to 2 concurrent component failures. So what does that actually mean in practice? So are we talking about a node failure? Are we talking about a disk failure? Are we talking about RAM, DIMM failure? Well, the answer is yes. Any of those would represent a component failure that takes out a node. And so because of that, you're able to tolerate those in terms of cluster level. Um, so if you need enhanced, you need more individual nodes to get to that enhanced fault tolerance level. So in a 3-node cluster, we can do fault tolerance of 1. There'll be 3 copies of the metadata across the cluster nodes. In a fault tolerance level of 2, we're going to need at least 5 nodes in the cluster so that we can have 5 copies of the metadata. And that sort of makes sense, right? So if we've got a distributed system and we've got 5 nodes here and we're running multiple copies of things, we need the capacity and we need the node count in order to recover from 2 failures. So if we've got node 4 and 5 out, the other 3 nodes can completely self-heal and bring everything back up to a completely healthy and non-degraded state. We couldn't do that if we lost 2 nodes in a 3-node cluster. We need more nodes to be able to handle this at the cluster level. This is something that can be changed if the conditions are met, and it's a background operation, so it is adjustable in a cluster. And that's the bigger concept of resiliency at the cluster level. But let's talk about it from a file system or data resiliency standpoint. So these are 2 different things. So when we're talking at the cluster level, we're talking about losing a node. When we're talking about data resiliency, we're talking about other types of failures, possibly disk failures, things within the system where it may not be a total node failure, or it could be, but now how do we protect the actual data? So there's 2 different ways we protect data inside of the storage pool. We call it RF2 or RFT, or excuse me, RF3. RF2 stands for redundancy factor 2. Redundancy factor 2 really means about the same thing as FT of 1. We can lose 1 node in the cluster and continue running. So RF2 and FT1, kind of the same thing, but they're at different layers, right? One is at the cluster level, one is at the data level. And so RF2 means there's going to be 2 copies of every block of data replicated throughout the cluster nodes. Same way, RF3 and FT of 2 are kind of the same concept. Not the same thing, but the same concept. And with RF3, we're going to have 3 copies of data maintained throughout the cluster. And because we have 3 copies of data, we need more than 3 nodes. So 5 minimum for an RF3. And we want to make sure that we've got enough places to manage all of those blocks and make sure that those writes get placed, both locally and to all of the replicas throughout the system. So how does that actually look in practice? Well, we've got a block here from this VM. RF2 is going to acknowledge it once it's written to the local and 1 remote node. So it's not going to acknowledge it until it goes to both. In an RF3 situation, we're going to write this orange-ish, peachish, I'm not sure what color that is, block to node 1, and then it's going to get replicated to 2 others. And it's not going to acknowledge that the block was written until it's at all 3. And so This becomes a conversation of, where do I need my most critical systems, that I need most in my business. So I need 3 copies of that. So SQL servers maybe, or transactional systems that you rely on for your system. This is tunable. If you have enough nodes in a cluster, you can tune this, and not all VMs have to be created the same. Some VMs can be purple, some VMs can be peach. And so you get the ability to tune this as needed, eliminating any one size fit all kind of issues that you may run into with other platforms. Resiliency from hardware failure. So Nutanix self-healing, it begins immediately. So as soon as there's a problem with a node, in this case, node number 1 goes down, the virtual machine is going to automatically move to the next node. So that's HA. You have HA within any of the hypervisors that we talk about. It relies on that core hypervisor technology, restarts the virtual machine. And then because AOS is running the file system underneath, as we talked about, it brings all of those blocks of data locally. So as soon as the failure happens, all those blocks of data are now gone that were locally running on node 1. So the cluster is going to automatically rebuild those on other cluster nodes for redundancy. And then it's going to bring them locally to the virtual machine that's running. So this is fully distributed, automatically happens in the background with no human intervention. And that's part of the distributed architecture. You don't want to have to press a button for these functions to happen. This should happen automatically without anyone touching anything. So you can monitor the progress and the performance inside of the Prism element or Prism Central UIs. You have the ability to see how things are going. And this is true whether it's an unplanned outage or whether it's a maintenance window that goes long because something fails and doesn't reboot properly. Any of those failure sort of scenarios, whether planned or unplanned, this is going to be the same self-healing that happens at the data layer. Now, what happens when we lose the next one? Well, we still have 3 nodes. The same sort of operation is going to happen. We get an HA restart of the virtual machine. It's going to rebuild and bring things locally again. And we're back to fully healed. So we got the concept of data locality, bringing all of those blocks local to node 3. And then we've got the distributed fabric where everything's got another copy on another node in the system. So both of those things at play. So what happens if that all-important CVM has a failure? Or what happens during patching? We can actually patch AOS, restarting the CVM in a live cluster with no disruption. So in the case that your CVM happens to go down, you're also able to talk to the CVMs in other nodes in the cluster. So if on node 3 our CVM were to fail, we would be able to talk over the wire and receive blocks A, B, and C from the other nodes in the cluster until the CVM reboots and comes back online. So I guess the thing I'm saying is whether it's an unplanned or a maintenance activity, you've got the protections against all of these different types of failures. So Chris has got a question here. Is there a witness node in that if you were to lose more nodes than a cluster can sustain, you could not recover those nodes? Would the remaining node have fully metadata in the cluster, or is it in a database? So we do need a quorum. And in general, we don't run witness nodes except in specialty use cases. So 2-node clusters have the ability to have a witness node. So there are certain use cases in Robo and Edge where a 2-node cluster may make sense. That does have the witness node as a component. But in general, we start with 3-node minimum, and 2 nodes have to be online to keep the cluster and all workloads online. So there is a concept of a single node cluster, There's a lot of restrictions that go along with single node clusters, in that you can't grow them. And so a lot of the things, a lot of the goodness that we get from Nutanix aren't available to you in a single node cluster, but those concepts do exist. But good question again. And hopefully I got the answer for you there, Chris. So when we're talking about a CVM failure or any number of different failures, the behind the scenes stuff gets complex, but it's really handled for you. So when Stargate sees I/O errors on a device, it's going to automatically respond within a certain threshold, and it'll mark the disk as offline. And then once that's occurred, another subsystem inside of Nutanix will start to run smart and check the status of the device. If the disk stays offline multiple times, currently about three times in an hour, it's going to mark that disk as offline, even if it's it's going to continue to mark it offline even if it's passing self-tests. At that point, reprotection kind of kicks in. And so this is very similar to what you would see in a RAID rebuild. Once the disk is removed or it stops responding, it's going to start that evaluation, rebuild. A subsystem called Curator begins to scan and identify what data is missing. It will re-replicate the data to all the other distributed nodes. And then AOS distributes that across the entire system. And so when we start talking about AOS, we've got different subcomponents that handle different functions. And so when we talk about metadata, that's in a system called Cassandra. Curator is this piece that helps us during resiliency and failure. It goes through and it scans to help us find the pieces and put it back together. A disk failure that includes the boot disk is a different type of failure. That one, it will re-heal, it will self-heal once the drive's been replaced. So there's a number of different conditions that may happen. So we're talking about the data pool, the storage pool. We're talking about the boot. All of these things have been thought out, and we have the ability to recover from all of those with automation. That's a big part of the simplicity. You don't necessarily have to go into the weeds like we're talking about today to benefit from that. The simplicity gets masked away into a UI. You can see it inside of that data resiliency widget, and that can help you keep moving forward. So let's see. Next step is availability zones. One other question. Can AOS or other node cluster specific settings metadata be backed up off the cluster for emergency recovery? Not really at that granular of a level. Everything inside of the cluster is there for the benefit of the workloads that are running in the cluster. So we do have backup integrations with Veeam, Haiku, Cohesity, any number of different vendors that back up the data we care about. The metadata within a cluster is not necessarily something we care about because it only helps to run that cluster, and it is critically important at that point in time and changes so often that there's not much of a benefit to backing up the metadata. From a cluster settings perspective, we can replicate some of those settings, and that's where Prism Central comes into play with certain configurations and things like that. So I would say between a combination of Prism Central and replication, we get that natively, and then within add-on software, we get backup and recovery for the actual workloads we care about living within a cluster. So availability domains. We also talk about this in terms of block and rack awareness. And so um, what's a block and what's a rack? Well, rack's pretty simple. It's that big 48U thing we mount our servers in. But a block may not be a concept that you're aware of. So a block is just a chassis with more than one server running in the same chassis. And so this is important because in the Nutanix NX line, in certain HPE models, we can run multiple servers from a single set of power supplies. So that makes them susceptible, like a blade server, to having a domain failure within that block, that hardware configuration. And so we have this idea of block awareness. In the NX line, we can run up to 4 nodes in certain models on the same 2 power supplies. And so we have the ability to label all 4 of those nodes as a block. And so in this concept on screen, any one of these purple shapes could be a block and have 4 nodes in it. And so when we turn on block awareness, we have to have a minimum number of blocks and we have to have a minimum number of nodes to turn this on. And again, it becomes a best effort sort of configuration to balance the workloads, the data out so that we don't lose the entire cluster if any one of these 5 groupings goes away. So this is a standard enabled in every Nutanix cluster. They're capable. You have to have enough nodes in order to be able to do this, but it allows you to lose one complete purple block here and survive. So some of the things that come. So we currently support we currently support these levels of awareness for availability zones. So disk is always, node is always, block awareness came in version 4 and rack awareness comes in version 5 of AOS. Current version, long-term service release is version 6. So if you're current on your software, you're able to run block or rack awareness on any current version. What happens is it partitions out the metadata, the data, and makes sure that there's replication amongst all of these zones. So let's go through an example. You got your cluster configuration right now sitting in 3 of the 5 blocks. We've got our metadata sitting in all 5 of the blocks. And then our data is sitting in 3 of the blocks. So what's going to happen is we get to replicate this data out. So we've got another copy of metadata on 3 of the nodes. The data is starting to replicate out. We lose a block. What's going to happen is now it starts to check and starts to rebuild this data across the other blocks. So just like we had resiliency within a node or a cluster with the storage system, we've now taken this up a level and we've said, okay, within these 4 nodes, we need to make the same protections and effectively give ourselves RF2 or RF3 writing the data across, the defined number of these blocks to protect us. So this is important sometimes when we start to get into super large clusters or metro sites, which is another feature, synchronous split clusters into metro regions, maybe different computing rooms. So we have the ability to configure multiple different ways in the same software UI for different use cases. But again, this is targeting specifically this concept of multi-node blocks and rack awareness within the cluster. So why is it important? Why does it matter? Well, Nutanix is serious about data integrity. This is a storage system at the end of the day. When I first started as a young systems administrator, our storage systems were some of the best tested systems in the data center. And that's because the manufacturers were going through such rigorous regression testing on every release of software and every hardware release because they were dealing with the crown jewels, and Nutanix is no different. They're dealing with your crown jewels, your data. So, very serious about data integrity. This reduces your risk of failure and losing any type of data. There's no node or disk hotspots during rebuilds. This is a distributed system, and so that helps us to avoid these hotspot concepts so you can minimize impact on your production running applications while these background rebuilds are happening. And then your rebuild times are faster because you get more of the metadata distribution in current software versions, and that helps reduce the overall risk of downtime and helps us get to a fully rebuilt state faster. Speaking of faster, let's take a quick break. I'm going to take a 5-minute break. We're at the top of the hour. And what I'm going to do during the break is send out information to get you logged into the lab. And then about maybe 2:10, we will get started with performance, kind of wrap up what we're talking about in the deep dive, and then get you into the lab environment so you can actually touch and feel this for yourself. So 10-minute break, and we'll resume.
All right, welcome back, everyone. Cool. So let's go ahead and kick off talking about performance. And Phil will work in the background to get you guys the lab credentials and lab access. But it should be a really good lab, right? We have a hosted POC that you're gonna log into and have your own cluster to play around and learn Prism Element and Prism Central. So I think it'll be a really good lab for you guys for sure. But let's go over performance, right? So this is what it look like when you do read and write. So we have something what we call a hypervisor pass-through. We're actually going to write data and going to pass through the hypervisor as well for faster performance. It's going to write, it's going to go through Stargate, which is kind of our data mover. It's going to go and log in information into our op log. I think someone was asking about metadata. This is where the metadata is on the op log. Usually we have the op log hosted on the first two disks. Once we have an op log, we'll then flush it into the extent store, which is our software-defined storage. Next slide. We have a concept that we call data locality. This is kind of our differentiator from not just Nutanix and other competitors, but other software-defined storage network as well, right? Without data locality, let's say you have multiple servers, multiple storages. Your VM could reside in node 1, but that data could reside in node 4 or 5, right? You would have to read and hop through the network to receive that data. But with Nutanix, whatever VM node it sits on, that data is going to sit locally as well for faster read and write. You see here, we're going to read locally. If the VM moves, the data will move with that data. And then we're going to stripe across for RF2 and RF3. So with live vMotion, live migration, wherever the VM moves, we'll move that data with you, hence data locality. And faster access to your data. Next slide. So AOS has been around for a very, very long time. I think we started our company maybe 15 years or so, back in 2009, 2010. But we've been gradually growing and building out our product ever since. So now AOS is on version 6.10. Version 7.0 is coming up pretty soon. A lot of new advancements is coming up. And we'll update you guys as a customer as all the releases comes out. Very simple to update. It's a one-click operation within Nutanix. Let's go into the Prism Element console, which we'll see in the lab. And a single click of a button will upgrade the AOS, AHV, and everything within the environment.
One of the things here I think that's important is that because it's software, all of these things have been delivered as additional value, additional performance to existing customers of AOS. And so some of the examples that we're going to go through here in the performance section are ways that things have been re-architected over time in software for your benefit.
We can also leverage RDMA. Right, we can pass through a lot of different things, standardize, and go through RDMA for faster read and writes. Phil, if you go to the next slide, this will make a little more sense what I mean by simplifying RDMA. So we have our own, if you guys are familiar with VMware and VMware Switch, we have OVS switch that will separate out for VM traffic. Most of our traffic, VM traffic and stores will go through the OVS and VM kernel. If you go to the next slide, with the release of 5.10, sorry, if we can go to the next slide. Release of 5.10 and version 5, we can have a separate networking. You click one more, Phil. we can have a separate networking for RDMA traffic. Similar to our replication or volume iSCSI or DR, we can actually have a separate traffic for each of those data movements. But for the most part, right, 90% of our customers just have it all in ETH1 in one traffic network. But if need be, right, we can have a separate one for RDMA, replication factor, volume, and DR. Next slide. We can extend our data locality with global metadata between the different clusters. Next slide. Go to the next slide. Let's go to the next slide, Phil.
Yeah, I will talk real quick
Oh,
about
okay.
this. One of the things that you see here, and we talked about this, because Nutanix has been around for a while, we used to have Stargate talking to file system and then directly to the SSDs. That got simplified over time by including block store in Stargate. And then it's been further simplified as we move away from SCSI towards PCIe with NVMe. This has continued to evolve. And so SPDK allows us to continue to scale overall performance for the disk subsystems. And so, we've got this new way of talking to NVMEs that help us really accelerate the speed that we deliver to customers. And so, as we look at this, the new generations of AOS can provide 1.5 or 1.25 times the overall IOPS but also reduce the latency in half. So that's a pretty huge step forward overall in terms of performance. It opened up AOS to a slew of new applications, more workloads, more density, all of those kinds of things, and all of this delivered directly to customers through software. This wasn't, again, anything reliant on, um, specialty hardware. This is all commodity hardware with software. Databases has been a huge place as well. And this came up in a recent Lunch and Learn talking about database performance. And so the old way of Nutanix handling this, the hypervisor talked to Stargate. There was a single vDisk controller going to a single vDisk. And so we ended up with a throttle or a bottleneck a lot of times. And so best practice for Microsoft SQL and Oracle is to break out your data files, your log files, and your tempdb into multiple disks and stripe across that. And so you get additional Windows operating system disk queues, you get additional storage system disk queues, and so you avoid saturating that connection. And so in the old way, performance was not that great when you had a single vDisk. And so to really make databases go faster, you had to follow that Microsoft best practice. That wasn't something specific to Nutanix. You had to follow that Microsoft best practice to really get amazing performance. But what's happened is the software has been updated so that now we have multiple lanes coming from the vDisk controller. And so we've got multiple IO threads between the CVM and the vDisk. So even in a non-optimal configuration for SQL on a single vDisk, you're now seeing significant performance increases for your databases. But I say all of that, and I'll give you another illustration. I was a former Pure Storage customer with very large physical SQL servers in my last company before coming to XenTegra. We adopted the same concepts that Nutanix recommends for best practices with SQL on that physical Windows with Pure Storage, and we got the same amazing performance increases. So it's not something specific to Nutanix. This is a universal sort of SQL best practice to spread out the workloads across multiple different virtual disks. But again, this is also delivered in software. As the newer releases come out, we've made some technical changes that have continued to bolster faster workloads, particularly around database. And so as we look at this, we've gotten 2x performance off of a single vdisk, 77% performance improvement with a single data file. And so both of these use cases end up with significantly a better performance for your SQL and other transactional type workloads. I did a podcast episode recently around MLPerf, which is Nutanix files for AI workloads, and the same sort of thing is found there. It's now a tremendous platform for running files behind AI to be able to outperform some of the largest distributed file systems like Weka and others that are purpose-built for fast file access, now using the same technology here delivered from Nutanix. And so why does it matter? Your replicas are placed in the best possible location. That reduces cost and risk based on the fact that the system is doing that for you. You get data locality, as Paul said, part of the critical secret sauce, avoids noisy neighbor and network hops, and it minimizes network chatter while optimizing performance for your applications. There's no dedicated caching drives for performance, which also reduces complexity inside of the design. Paul, I'll pass it back to you for data efficiency.
Yeah, within Nutanix, we have both compression and deduplication built in to our product. It is on a container basis. A container data store for us, for whatever reason, right? You can have all VM workloads on one container, but if you want to separate them out, let's say you have databases that you don't want to have compression or dedupe on, you can turn those off. Again, they're on a container basis. Next slide. We have eraser coding as well within Nutanix. This helps, right, kind of eliminate more extra nodes. But for eraser coding, we do need at least 4 nodes. What it does is it creates kind of the 4th node is kind of the parity node. So you see either A and B, it's going to have them both on that 4th node. So if block 1 with A goes down, that 4th node can rebuild with that letter A. So it's just kind of another backup sequence. Think of it similar to like RAID 5 or RAID 6, right, with that parity. That 4th node is going to be your parity rebuild block. Yeah, the bigger environment you have, the more savings you're going to get with the razor coding. And right, the extra one is your parity block. But the bigger environment, the more savings you're going to see. And then razor coding is there if you want to go ahead and enable. Cool. Next slide. Oh, same thing. This is going over deduplication. I don't think we need to go deeper dive on what compression duplications are. But again, right, dedupe and compress are on the container level. And then a container for Nutanix is the same thing as a data store for VMware. We have native snapshots built in to our product. Right, it's similar to any other storage solutions, right? When you have snapshots, those are going to be for planned outages. If you want to do an upgrade, but you just want to test it out maybe, or maybe want to recover and go back, those snapshots are good for those instances. You can do snapshot to the same cluster, or set up snapshots and do DR to a secondary cluster. We also have something called MST, multi-snapshot technology, that can also send out snapshots directly into AWS S3 or Azure Blob for the cloud environment. If you don't have a physical DR site to replicate your snapshots to, simple button, right? Use MST, replicate those snapshots out into AWS S3 or Azure Blob, and you have backup another location. Right? The best practice for backups is, if you have the cost for it, have as many as many backup data in different locations as you can. So it's built in a native within Nutanix. And then we won't dive into it, but absolutely, right? You can also pair up, have true enterprise backup solution with, like Philip mentioned, Veeam, Haiku, Rubrik, Cohesity of the worlds. Next slide. Oh, and lab time. And I think in the lab as well, you're going to create protection domains to back up your VMs. And that's where you create, right, those snapshots and where those snaps are going to reside and how often you want those snapshots to be. And then set up your mission criticals and your other separated backups and create those protection domains.
So another great question from Chris in chat. How aware is AOS of the status or degradation of physical hardware in the box?
So we have a concept we call NC2, Nutanix Cloud Clusters. So two ways we can do this, right? We can put our software on an AWS bare metal. So that's going to be, it's going to be seen as an extension of Nutanix. So it'll be just like a secondary site. We go with NC2, everything will be aware, right? Because then it's within your Nutanix infrastructure. However, if you're just replicating your snapshots to AWS S3 through MST, that's when you would have to build out, right, your EC2 instances and build a whole environment to recover. Again, those snapshots, right, are just being held as a safety backup, holding your backup data. To recover is a different story. Again, that's where I would recommend going with NC2. NC2, it's to say no extra, right? The license is the same as you would license an on-prem Nutanix. Again, it just sees AWS as a secondary site. Once it's within a Nutanix infrastructure, you can manage everything within Prism Element and Prism Central.
And
so, good question.
Yeah, and then for AOS status of physical hardware, it's a co-authored sort of solution between both the OEM server vendor and Nutanix. But a lot of the sensors and things that are inside of the box are now exposed through the IPMI or the iDRAC or the ILO, whatever the vendor calls their out-of-band management. And so Nutanix is able to monitor physical hardware through that common API as well. So it uses and piggybacks a lot on the Redfish API, which is the open source for IPMI, or not open source, the open standard for IPMI APIs. And so a lot of the things that happen during automation and creation of a cluster use that Redfish API, the IPMI interface, to automate and create the cluster. And so the same thing's true when it comes to monitoring the physical hardware.
Oh, apologies. I misunderstood the question.
No worries.
Yes, everything Phil says correct. We can also have blinking lights as well.
Yeah.
So if we know which hard drive is degrading, we can also select the hard drive so we can flash a light. So whoever goes into the data center pulls out the right one and not the wrong one. So a lot of backups, a lot of functionality around that as well.
All right. I know you are waiting on these emails anxiously. I apologize that they were not done before. I can't walk and chew gum at the same time, and so I now have them sending out. So a couple things to note. We're going to need to go out to a website. There's a couple of links in here. We're going to try a primary website to go to. That is the Frame access point. So Frame is a VDI type technology. And so we're going to go out to that as soon as I get you the emails, and that'll get you started. So sending that now to everyone. Finish and merge. They should be on their way to you, and I apologize that it's taking this long to get there. But you'll see a link first in the email to the lab guide. That magic link will get everything pulled up so that you can get started. And as we go through lab time, myself and Rob and Chris, we're going to be here in the room to help moderate. We want to thank Paul for his time today. And we appreciate you spending time teaching alongside me. So thanks, Paul. And hopefully those emails are coming in. If anyone's missing their email here in the next couple minutes, reach out and chat. We'll get you set up in here, and we'll get you online and working so that we can start the lab. So look for those. I'm going to go ahead and stop recording now.